This is Algebra 2, Chapter 13, Section 5, in which we will be solving trigonometric equations. Our main strategy in solving these kinds of problems is going to be to do some factoring first, and then use inverse trig to finish the problem. So all of our factoring rules that we've been working on all year are going to come right back into play again. This includes looking for common factors. This includes difference of squares. This includes general trinomial factoring, where we do factors of this that add up to that. All of those skills that we've been working on so hard all year, they're still here. So our first job is to solve this equation, sine x times cosine x minus 1/2 times cosine x equals 0. Now, I'm looking at this and I see a common factor right away. Both of those terms have cosine x in them. So I'm going to factor out the cosine x. Now I've got two factors equal to 0, so I split them into two separate problems. In the first case, cosine x just equals 0. In the second case, sine x minus 1/2 equals 0. So I brought the half over. So in our first problem, x is going to be equal to the inverse cosine of 0, which is 90 degrees. In our second one, it will be the inverse sine of 1/2, which is 30 degrees. Now, there are more solutions than just these two. There's always more angles that give you a cosine equal to 0. 270 comes to mind, negative 90 comes to mind. Okay, I'm not going to make you find all of them. I'm just looking for the principal one, the primary one that your calculator will give you. So don't sweat having to look for, every possible angle, because you'll never find them all. Just work off of the primary, the principal that your calculator comes up with. Let's take a look at our second problem. We have sine squared x plus 2 cosine squared x equals 1/2. Okay. There's no common factors in there. But I do recall one of our Pythagorean identities that I can get sine squared x by itself in by subtracting cosine squared x over. Okay. Now I can substitute that in place of sine squared x. Okay. I'm going to do a little bit of cleanup work. Negative cosine squared plus 2 cosine squared gives me positive cosine squared. And if I subtract the 1, I get 0.5. When I take the square root, I get two possibilities, a positive and a negative. So I need to consider both options. If I inverse cosine 0.707, I get 45. If I inverse cosine negative 0.707, it gives me 135. Now, when I did this on my calculator, I left the full value 0.707 and all the rest of the decimals on there. So I was able to get an exact 45. You might get like 44.9 or something like that if you round it off. But that's okay. We're in the same neighborhood, and that's what really matters. And again, there are other solutions, but I'm just focused on the primaries. One more problem that looks a little bit scarier, because the first thing you notice is, oh my gosh, there's a fourth power. Don't panic. There'll be plenty of time for that later. Okay. I need to get these to be the same function. So I either need secants here or tangents here. And one of our Pythagorean identities says 1 plus tangent squared is equal to secant squared. Back on your 13.1a notes on the second slide where you have the Pythagorean identities, this is one of them. So I can substitute this stuff in place of secant squared. Well, I'm going to distribute, and then I'm going to move everything over to the right because it's a lot easier to factor things if they're on the positive on the lead term. So we need factors of 3 that subtract to make 2. Well, that's 3 and 1. Okay. Since it was tangent to the fourth, I need tan squared and tan squared. Well, I'm going to split these into two problems. Tangent squared equals 3, or tangent squared equals -1. When I take the square root, I get positive and negative 1.732. Again, I've more numbers here, but I chopped it off. If I take the square root of this one, I get no solution. So this half of the problem is done. Okay. Now we're going to take inverse tangent of the negative case and inverse tangent of the positive case. I don't know why I did the negative first, but I did. In any rate, we get two values, -60 and +60. Okay. Again, your mileage may vary. You may have a slightly different answer there if you left exactly that number in your calculator. Me, I left the whole square root of 3 in there to work from. So you're going to do a lot of work here with factoring. So your factoring skills are going to come into play one more time here. You're going to make some substitutions, mostly using Pythagorean. And then you're going to do inverse trig to finish the problem out. If you had questions along the way, hopefully you wrote those down, bring them in with you, and we will see you in class.